Hi students, in this video we will be going over the product and power rule of exponents. Our essential question for today is, how is the product and power rule used to simplify exponential expressions? So once again, how is the product and power rule used to simplify exponential expressions? So first let's talk about the product rule. But before we do that, let's talk about the parts of the exponent first. So there are two parts of the exponent. There is the base, and this is the number that is being multiplied. And then you've also got your exponent, which is the number that states how many times the number is being multiplied. So for instance, if you look at this, the base is the number that is being multiplied. So the x is the thing that is being multiplied. But the exponent represents how many times we see it being multiplied. So since it's x to the fifth, that's 1, 2, 3, 4, 5 times. So those are the parts of an exponent. Now the product rule states that when multiplying two powers that have the same base, you add the exponents. Now you would see the product rule using the multiplication sign because product is an answer to a multiplication problem. And all this is telling you to do is simply to add the exponents together. So you would have 2 plus 7 plus 3, and that equals 12. And that's it. That's all you do. Pretty easy, right? So now let's look at some examples, some easier ones, and then of course some more difficult ones. So first on this one, we have got all the same bases, which means all of those can be combined. So what you do is you take that base and then you simply add all the exponents together. And that gives you x to the 10th. And again, that's it. That's that easy. Now, this one is a little bit more advanced, but the nice thing is when you look at the variable, you still see that it's all the same base. It's all the same variable, which is y. However, with these numbers out front, the 4 and the 2, all that you have to do to combine those is you just multiply it. So 4 times 2 is going to be, is going to be 8. And then you would simply add the exponents together since they have the same base. Now, if they didn't have the same base, that's a different story, and we'll talk about that in a second. But all we did is we just multiply those coefficients together to get 8, and then we add up those exponents, and our final answer would just be 8y to the 9th. All right, now let's talk about one other rule before we get to some more advanced problems, and this is called the zero exponent rule. And this is the easiest rule of exponents. All it states is that the zero rule states that any base to the power of 0 is equal to 1. So for instance, if you have y to the 0 power, that is just 1. That's it. So that is one of the easiest rules. So now let's look at some examples with the product rule and the zero exponent rule. So if we have one like this, you can see a couple things here. We've got some coefficients. We've got a couple different variables, which means a couple different bases. So we've got some x's and we've got a y. So with the 2's, we can just multiply them. So 2 times 2 would be 4 in a second. But before that, let's kind of get rid of that x to the 0 because that will help us simplify that a little bit more. So x to the 0 is the same as 1. So when you write that, you just take out that x to the 0 and you put 1 in the place of it. And 2 times 1 is just 2. So now our problem looks like that. Basically, it's kind of like this just goes away because 2 times 1 is itself, so it just becomes 2. Now we can combine our coefficients and we can start combining our bases. Now remember, this y, this is a different base. It cannot be combined with the x's. That needs to just stay with itself because it's just a y and it's all by itself. So 2 times 2 is 4, and then we know we have to add the exponents of the x's because x is a common base. So we've got 4 plus 3. And again, y to the second is going to stay by itself because there's nothing else for it to be combined with. So once we add our exponents, we get 4, x to the 7th, y to the 2nd. And that is it. Now let's look at one more problem. So as you can see, we've got some coefficients, and these are kind of like bases as well. You could write them to exponents if you wanted to, so like 2 and 2, that's 2 to the second, or you can just multiply them like we've been doing, which I think is kind of easier. We've got some other bases here. We've got m's, and we've also have p's. And I also see over here we've got m to the 0. So m to the 0 again is 1. And basically that just becomes a 3 because 3 times 1 is 3. So that simplified it a little bit. Now what we're going to do is we're just going to rewrite this by combining our coefficients. And then we're going to take all of our bases, so all of our m's, and show that we're adding them together. And we're going to take all of our p's and show that we're adding them together. So let me explain what just happened, just in case you're not following that. So 2 times 3 is 12. We combined our coefficients. Now m, we only have 2 m's left, and with the same bases, when we're multiplying, we have to add those exponents, so I have 5 plus 6. Now p has quite a few exponents. It's got 4, 3, and 2, and since p is a common base, we can combine all those exponents together. Once you add those exponents, you get 12, m to the 11th, and p to the 9th. And that is it. All right, you have 2 practice problems to try. Give those a shot and put your answers in the Edpuzzle. All right, power rule. So what is the power rule? The power rule of exponents states that to raise a power to a power, you need to multiply the exponents. So before, when you're multiplying your exponents, you add them together. Seems kind of weird, right? But when you have a power to a power, you need to multiply them. And the power to the power is represented by parentheses. So that means there is some sort of expression on the inside and a parenthesis, or an exponent outside the parentheses, saying that you're raising this power in here to another power. Now, to kind of visually explain this, what you can do is think about when we were doing, just kind of as a side note, when we had y to the second times y to the third, and we said, oh, we have to add those, really you're talking about y times y times y times y times y, because you've got y to the second and y to the third. So obviously that gives you y to the fifth. So that's how that works in the product rule. However, this time with the power rule, it's a little bit different. Okay, so the power rule, you're kind of talking about sets of numbers. So you're talking about having basically a set of 3 y's here, and you're talking about having another set of 3 y's. So you've got 2 sets of 3 y's. So again, this is saying it's y to the third times y to the third, which is y third to the second. Now, when you add all those y's up together, okay, you get y to the sixth, which is why the power rule states that you have to multiply them, because 3 times 2 is 6, but when you expand this out and you stretch it out, you see that you have 6 y's instead of 5 y's. So that's how the product rule and the power rule are different. They're different in the ways that you kind of combine those y's and you put them into groups. So like we just said then, this would simply be multiplying the exponents, and you get y to the sixth. All right, so let's look at this one first. And this is z to the third, and then all of that is to the fifth. So again, you're talking about having 5 groups of z to the third. And the easiest way to solve this, instead of writing it all out like we did on the last slide and putting z times z times z and doing that 5 times, you now know that you simply can multiply them to get z to the 15th. Okay, so let's look at another one. Now this is a little bit different this time in the sense that you have got several, now you've got 2 things in there, and kind of think it's almost like distributing. So you're taking this 3 and it's going to that 2, but it's also going to this x to the second. So you're applying that 3 to everything on the inside. So that becomes 2 to the third, okay, and x to the second times 3. So remember, because you're multiplying those. So you have to have that exponent go to everything inside. Now 2 to the third is just going, or I'm sorry, x to the second times 3 gives us x to the 6th, and then 2 to the 3rd is simply 8. And you've got 8x to the 6th. Okay, so let's look at another one. Now this time we've got 3 terms inside. So again, just like we did last time, you have to apply that exponent on the outside to everything on the inside. So you have to apply it to the 3, to the x, and to the y. And remember, the power rule says that you multiply. So that ends up becoming 3 to the 3rd, and then x to the 2nd times that 3, and y to the 4th times 3. And when you simplify all that, 3 to the 3rd becomes 27. This becomes x to the 6th, and y becomes y to the 12th. All right, let's look at one more example. This one is probably your easiest one. Now, there is a 0 outside of everything that is in the parentheses. So all that this equals, very simply, is 1. Now, if you wanted to take kind of the long way around on this, you could say, okay, well, that becomes 3 to the 0, and this becomes x times, or 2 times 0, and y 4 times 0. But then in the end, this just becomes 1, right? This just becomes 1, and everything just is going to become 1 because it's all to the 0 power. So since that 0 is on the outside, you know that everything is going to become just 1. All right, here are a couple of practice problems. Give those a shot and submit your answers on Edpuzzle. All right, last one. Now let's talk about some problems where we combine both the product and the power rule together. Now this probably looks a little bit scary, but you just need to walk yourself through your rules and go step by step. So if we look at this left side, there really is nothing I can do right now with that. But I do see there's a lot I can do on the right side because I've got this exponent and this is going to go to everything inside. So let's start with distributing that 5 to everything on the inside and simplify that first. So when I do that, we end up having to multiply all those exponents by 5. So it looks a little bit messy, but we're just showing that we have to multiply all those exponents by 5, which gives me now x to the 10th, y to the 15th, z to the 20th. Now here is what you see. Now since we have no more parentheses, we just see multiplication. And so now we're back to that product rule, and the product rule says that you add the exponents. So I see I've got an x, and if you never see a exponent, what that tells you is that that is x to the 1st. Okay, so that's x to the 1st. So I've got x to the 1st and x to the 10th that can be combined. I've got y to the 5th and y to the 15th that can be combined, but there are no other z's, so we know that z to the 20th is just going to stay. So we show that we're going to add all these together. We've got x to the 10th and to the 1st, y to the 15th and the 5th, and when we combine all those together, we get x to the 11th, y to the 20th, and z to the 20th. So although that looked really scary at first, once you combined up here and you started using that power rule, it became pretty easy, and you just follow the power rule, and then it went down to solving with the product rule. Usually that's how it works, and the product rule is kind of what finishes everything off. All right, it looks like our answer kind of got a little bit weird here, our question. So this should actually be to the 0 power. So this should actually be to the 0 power. So the very first thing to note on this is that 0 power. And that is really helpful because if we applied that 0 to everything on the inside, it's all going to become to the 0 powered, which means everything right there just simply equals 1. So now that problem is pretty much easy and done with, right? And now you just take your exponent out of here and you distribute that to everything on the inside. You multiply all those exponents. So we end up with 2 to the 4th, and then m to the 2nd times 4 now, and n to the 3rd now times 4. And when we simplify that, we simply get 16m to the 8th and n to the 12th. All right. So you've got a couple practice problems to try. Take a few minutes, try those problems, and input your answers into Edpuzzle. And if you have any questions, please let me know.